Today a look under the hood of this Supermicro SuperServer SYS-E200-8D system. This is a 6-core Xeon, and quickly looking under the hood, I've removed the screws, but I've got the hood in place. The machine is unplugged right now, and there's a quick look at the machine. What have I done here? Well, you'll notice 3 fans. So the marketing pictures have 3 fans, but when you get and take delivery of your system, it comes with only these 2 fans. Strange. So I took one of the fans out of this similar E300 box, which has a taller set of heatsink vanes, by the way, but also that's because it has room for a 2.5-inch drive to hover over there. 2 of them actually. But this machine has no room, right? If you're going to put a 2.5-inch drive, it goes right here underneath, and it's right over the CPU, so that's why the heatsink vanes are a little lower. What that also means is that your fans are running a little faster. So before we get started, we're going to start with how does the machine sound at factory defaults with 2 fans. So we're going to tuck that fan header out of the way, and now we're just starting with a stock system. Tuck those tabs under the back, slide this inner lid in place, close the outer lid, and now we have stock Supermicro SuperServer. I want you to be able to see the front bezel with the lights a little bit. Alright. Apply power, got IPMI already plugged in. Okay, a few things to point out here. One, I'm going to try to do this whole video in real time, meaning no cuts, no edits, just the actual content. Why? Well, probably because it's cumbersome to edit 4K video, but also I don't want you to feel like there might be any trickery or something I'm up to. Make sure you can see the watt meter there. There you go. So we're at 39 watts in this very early boot. Alright, what else is special? Well, you may have spotted I have a Samsung SM951 affordable M.2 NVMe drive. It's not SATA, it's NVMe. So it's a fast SSD and affordable. And, whoops, the IPMI app just had a problem. I've seen it happen on occasion. Now, during early boot, you're not going to see thermals or anything about the system. You have to wait for a beep. So not only did I add an NVMe drive that has Windows Server 2016 with Prime 95 abuse or CPU abuse tests set to auto start, which I have a video about how I did that. But also there's a speaker in there, so you're about to hear a little beep. And is our auditory cue that comes with bundled mini towers, and I'm considering a bundle here for this little 1U guy. Trying to make it more suited for home labs. This is much noisier than the mini tower, I will say. And if you go to tinkerchart.com/compare, you will see decibel levels near the bottom of that chart. Okay, watch for decibels drop, the fan RPM. Okay, so there's our baseline. The machine was powered off overnight. We were at around 70 Fahrenheit in the room. And you can get IPMI readings once the machine is finished power and self-tested and hear the fan RPM drop like that. So take note, 40 Celsius is where we start, and look at the decibels. So it seems like 50 is a fair value as it bounces around a little bit there. So 50 decibels to start. Now you hear it ramping up. And again, the reason you're hearing it ramp up is I've auto-started Prime 95. CPU core abuse, basically. It tries to heat up and basically damage the system as much as possible. A couple things to also note here. This is a 60 watt power brick, but actually we're obviously capable of hitting 80 watts with it. Okay, I'm going to move the exposure down and make sure you can see that IPMI readout in the middle there. Time to hit refresh. But before I do, there's the base RPM. It's not automatically refreshed. So we started at 4,500 RPM peak. And 40 Celsius. And you can hear the fan just keep on climbing. We've hit 67 Celsius already. Fan has climbed a bit there. So like I said, I'm just going to leave the video running in real time so you can get a picture. An overall picture of how the system performs and sounds potentially in your lab or home lab. Again, quite a bit louder than a mini tower. I have another video where I've recorded all the different form factors, a 1U, a mini tower, and then these two little 1Us, all in one sequential timeline, and that's what I used for the measurements that I published under tinkertray.com/compare. So we're getting near the end here, the highest value hit. I did a bit of a rehearsal in 71 Celsius, the highest I've seen. Today we're seeing about 70, and there it is, another fan RPM upping, 77, 71 Celsius, 7,900. And even after waiting a minute or two, we're unlikely to see much of a change in guide. So I'm also going to record the decibel level and the watts. So, hitting one more refresh, recording the values, and moving on in this video. 71, 7,900, yep. And decibels, let's have a look there. Alright, I moved up again. Not the best decibel meter, but I'm going to call that 62. 82 watts. 71 and 8,100 RPMs. Okay, what's next? Unplug. I have no static discharge, I'm not worried about that. It's a humid environment I'm in. Remove the inner cover. Now, install this fan header. Now I will point out, you do have plastic releases. They're pretty hard to reach with whatever tool you might consider. And frankly, they just give a little friction for that first couple of millimeters you need to clear for the fan to pull out. It'd be really hard to put a tool in there and actually not damage things worse or crank on this sideways. So I think you're better off with gentle upward pressure on all three cables. Alright, a couple things to point out too while we're in here. DC, right? AC is unused, DC only, goes right out the power at the back. Okay, so now we have ourselves a 3-fan system. If we did this while the machine was running, you'd end up with an amber light in front and a high RPM of 1200 RPM. But I'm trying to do the safest approach here, and that is unplugging the server before touching anything. You would not want to remove the inner lid. Okay, so let's get the decibel meter back again. Let's get power reapplied. Okay, front bezel, no amber lights. It's now a 3-fan system. So we're waiting for power and self-test to finish. And what I want to learn here is, how does the system perform at idle? And how does the system perform at heavy CPU stress? Those two extremes. I'll measure that for you and give you a sense of whether this is a better machine with 2 fans or 3 fans, or more suited for an environment where humans are anywhere near it. In general, that does mean larger fan diameter or more fans running at lesser RPM, but that's not always the case, which is why I'm taking the time to measure this. I know the decibel meter is not aimed optimally. I'm just trying to get it so you can see everything on camera as easily as possible. And I've actually gone with 4K to make sure if you have a high resolution screen you can benefit the most. So you remember I mentioned that those are going to show null values until you get past the beep, the power and self-test completion. Here you can see that is the case, very much the case. So not only do you have to wait for the beep, to wait till the fan RPM to settle down. Okay, we're starting a little higher, 44 instead of the 40 after an overnight, cool off. And the decibels are a little higher. Seems like about 51.5. I'm going to call it 51. The decibels are such an approximation and bouncing all over the place. Anyway. Alright. How are the RPMs? So I'm jotting down the numbers. Okay, here, cranking up now. And there goes the temperatures, and there goes the RPMs. We're seeing the decibels climb as well, of course. Alright, if the last time is any indication, and my rehearsal yesterday, that within a minute or so we will have leveled off in the RPM, maybe 2 minutes maximum. So it doesn't take too long for the RPMs to ramp up to try to accommodate the workload you're at, to try to avoid any thermal throttling. Now I've seen these systems get all the way to 96 Celsius, that's not anywhere near the threshold, which you can see in IPMI, I think is 100 5 Celsius or something before the system will just abruptly shut itself off to protect itself. We're obviously nowhere near that. We've got the lid on the cover, which is how you're supposed to run one of these servers. Admittedly, I don't have a 2.5-inch drive in there right now, which, of course, with its wiring harness would affect airflow a little bit. But, you know, I think they're going to become less and less common. I don't know if you have a 9mm tall or a 7mm tall. This test, I just went with one NVMe. Okay, we're at that same 82 on the high end for watt burn, it would seem. And CPU temp 64. We might be at the top of the CPU. I did notice better cooling with 3 fans. Not a big shock, but it's quite a bit better. 64. Probably wait about 1 more minute as I kind of close this out and make some verbal summary comments. So it took me about 16 minutes so far to show you this whole thing. People are asking me over and over, would I prefer this over a mini tower? And honestly, for my home lab, yes, my investment dollars went into the more expensive mini tower. Partly because I occasionally do 4K video renders, and you can see the tall CPU fan that's in there. But also I actually use a 10 terabyte 2.5-inch drive, so having front drive bays really handy. So there's lots of reasons you get more out of the mini tower, but the biggest is just the core count, and I actually use all my cores. And I have a graph of a 4K video rendered job that shows it scales pretty much linearly. So instead of a 4 or 6 core machine, I chose the 8 core for one and a 12 core for another, ZND1541 and ZND1567. What you're looking at today in front of you is a ZND1528 6 core system. So a nice compromise because it brings the price down well under $1,000, and even with memory DIMMs, you're hovering a little over $1,000 to load it up with a full 128 gig of RAM, which is what's in there today. Another question I get while we finish this up is, does the watt burn go up when you start adding ports for the Ethernet? So let's go ahead and do that and show you not substantially. Okay, power brick is moving, decimal meter's moving. That's unfortunate. I just happen to have a really short cable going here for one of these drops. So let me go ahead and finish wiring this thing up. So we've got a 1 gig, another 1 gig, a 10 gig, another. That's unfortunate, you couldn't see any of that. Alright, let's do that again. IPMI only. $83 watts. Let me finish recording these values. 64 Celsius. And RPMs, 7,000 is the highest one. Fan 1, 2, and 3, that's nice how that worked out. And decibels. Well, that's hard to tell. About 60, I'm going to say. I'm supposed to an approximation. And watts, the same 82. And I have terrible handwriting, that's why I'm going to make a chart out of this, of course. But you can see 2 fans, 2 to 3 fan config. We hit a lower high of 7,000 RPM, so the pitch or the whininess is less rather than 8100. The decibels is less, so 3 fans looks like an obvious advantage because we've dropped about 2 decibels. Temperature is quite a bit less, and then finally watts are unchanged. Did it just move a little bit? 66, it did. Okay, so we hit 7,200 RPM, 66 Celsius. Alright, so now I said I want to show you, let's get the exposure so you can see things. Now I'm going to add Ethernet cabling, see what that does to the system. So we're starting at 82 watts. Let's put ETH0, or the first Ethernet interface that Windows or VMware would see. It's the bottom left if you're looking at the back of the machine. Still 82. The other 1 gig interface. Now both 1 gig interfaces are attached. These are for your, in this case, Windows Server 2016, or Hyper-V. We now have 2 1 gig connections. Okay, we've gone up 1 watt. These are only 1-foot cables, very short. Now let's go to a 10 gig. And I do have drivers. Went up less than a watt, so not a big deal, and now 2 1 gigs. Somewhere around a watt per 1 gig drop. Again, 1 foot. This is with an ASUS switch that's very nearby. Let's see if I can show you that on camera. There you go. This is the ASUS switch. 8 1 gigs, 2 10 gig ports. These are 10 gig. And they're lit up with a different color blue that signifies the driver is loaded and 10 gig was negotiated. So I have to return the system. So that's it for looking at the E200, and hopefully you found this video helpful. Thanks for watching and for visiting tinkertry.com.